Recently, my friend Marc was showing me a project he's been working on, and I was absolutely captivated by what you're seeing here. On the one hand, the product of this robotic drawing is clearly depicting handwriting of some sort. But on closer inspection, you'll realize that it doesn't match with any known human language. That's because, in truth, this writing is actually complete nonsense. The scribbles you see on the page are merely a pile of total gibberish made specifically to mimic the look of handwriting. It's a form of art called Asemic script. The underlying system that creates these drawings is a complex artificial intelligence model with millions of parameters. It's trained on thousands of images of handwriting from various languages, and by the end of the video, you'll understand exactly how it works. Though before we get into all of those details, I think it makes for a really good lesson to lead you through how you might approach the task of generating Asemic script without the time, experience, or resources to create a super powerful AI. And if you follow along as I show you my attempt at doing so, there's a surprise coming at the end of the video that I think you'll find really gratifying. It's a pretty fun challenge to try tackling this problem in a simpler way, and I'd encourage everyone watching to pause the video here and spend a few moments thinking about how you would go about it before I reveal my own solution. First off, a defining characteristic of written languages is that there's a common set of characters used throughout longer sections of text. Let's first devise a method to create these characters. A common feature of many English letters, for example, is a vertical stem that serves as an anchor for the smaller strokes of the letter. These smaller strokes often come in the form of horizontal branches emanating from the stem. I think a simple way to create our characters would be to build them using this stem and branches idea. Again, using English letters as inspiration, I noticed that the stem isn't always the same length. So let's make the first step of creating a new character be to form a stem of some random length. For the branches, you'll notice that in the letter E, for example, there are 3 vertical positions that the branches come from. In the letter I, on the other hand, there are only 2. Let's keep track of how many of these branch positions our letters are going to have with a tunable setting. For now, let's go with 5 branch positions for our characters, meaning we add branches at all of these spots. As we go through this demo, we're going to create a whole host of various new settings for our generator, so let's keep track of them on the left-hand side of the screen, and later we'll be able to go back and tweak all of their values to see the effect on the output. Now, obviously, our character generation isn't quite hitting the mark yet. Again, using English as an example, one thing we could point to is that letters are often missing a lot of potential branches. For example, in our paradigm, these underlying skeletons minus these branches create the letters F and T, so we can try to incorporate that. To do so, we'll create another setting. This one will control the likelihood that any given branch in the underlying skeleton shape of our character will actually be included. To add some variety to our letters, I like the idea of sometimes adding a second, shorter stem a little farther to the right. We can then populate both of these stems with branches. Now that we can create characters, let's generate a bunch of them to form a character set for our language. And now is a good time to add a setting that controls the size of this character set, for which there's a lot of variability in the real world. Some languages are based around a relatively small alphabet, where individual letters are compounded together to make sounds of words. Others, such as Chinese for instance, use a multitude of symbols, which each represent a word or concept. For our language, we'll use 15 distinct characters for now. Once we have our character set, we can string them together to make words by separating relatively short sequences of characters with spaces. Of course, there should be some variation in the length of words, but also some languages tend to have longer words than others. For example, German words are slightly longer on average than English ones. So what you're seeing here is words with some predetermined average word length, where the length of each individual word slightly deviates from that average. So far, I think we've done a pretty good job of replicating the structure of text, but there's still something missing. To make it look like handwriting, we should probably incorporate some stylistic variations. These could be things like the height and tilt of characters, or the amount of space between characters, words, and whole lines of text. We also don't want every instance of a given character to look the same, so let's add a bit of noise to these parameters. Now, just like how you'll never write any given letter quite the same way twice, our program will draw characters a bit differently each time. We can also make the generator occasionally move on to the next line of text before reaching the end of the current line, which creates the look of paragraphs. Another important visual aspect of handwriting is the presence of mistakes and imperfections. For instance, many of us have probably had the experience of writing a long piece of text on paper and then suddenly realizing that we've run out of room near the bottom and forcing in a few more lines of text with progressively smaller letters. To imitate that, we can add a setting that gradually reduces the font size towards the bottom of the page. Another common trait of handwriting is that it's nearly impossible to write perfectly straight text without a guideline, so let's make our program replicate this challenge as well. Additionally, inspired by my own notebooks, I experimented with adding scratch-out markings over some words. With all of our new features, we can create a much wider variety of and much more realistic handwriting. I think we're ready to actually draw some of these with the robot. The way that works, by the way, is we use the algorithm we've created throughout this video to generate an SVG file, which is a format for vector graphics, and we send that file to the robot. After that, the robotic arm simply moves the pen around appropriately to replicate the drawing onto the piece of paper. Of course, the robotic arm will do slightly too good of a job reproducing our drawing. The straight lines will be perfectly straight, and strokes will intersect precisely. Normally, these would be considered good qualities for a robot to have. After all, much of robotics is about consistency and precision. But for our purposes, what we're trying to reproduce is human handwriting, which is fundamentally inconsistent and imprecise. Marc was able to create some extra variability in the drawings by using some springs to allow the pen to wobble as it draws. On the right-hand side of the screen, you can see the same SVG file drawn with the suspension mechanism. See how it looks so much more organic than the original version on the left? Viewing the script on a physical medium, drawn with shiny ink and slight natural wavering of the pen, really makes it come to life. With thoughtful adjustments of all the settings we've created, we can make images reminiscent of all sorts of different kinds of text. One of the reasons I love this project so much is because it perfectly marries together purely computational and purely artistic features which work together to create a result that effectively emulates both the structural aspects and the organic touch of written language. By now, we've come a long way with our generator, and the results are already pretty impressive. Although I promised at the beginning of this video that we'd eventually get to learn how Marc's actual project works. But here's the surprising part. Everything we just did, from the character generation to the stylistic variation, is exactly how Marc's actual project works. It's not a cutting-edge AI with millions of parameters. In fact, it's a simple program, a couple hundred lines of Python code with just a handful of settings, the ones we discussed in this video. You could write this program yourself with just a little bit of experience. My goal with this plot twist was to share the same sense of wonder I felt when I learned how this project works. At first, I was convinced that under the hood there was some complicated and difficult to understand algorithm, and I was shocked to learn just how simple it really was. I think that's a good takeaway for all of us. Sometimes it can be easy to assume that complicated results must be constructed by complicated means, but that's not always true. One of my favorite examples of this is Conway's Game of Life, where a starting condition evolves according to a short set of easy-to-follow rules. Oftentimes, the most intricate and wildly chaotic behaviors can be produced by the most elegant procedures. It's a reminder that starting with simplicity can often lead to surprisingly sophisticated solutions, and as problem solvers, I think we should all keep that in mind for the future. Despite the takeaway from this video, don't get me wrong, all of this is most certainly not to downplay the ever-growing importance of AI in the modern world. And while this video does not go in depth on that topic, I realize that many of you are probably eager to learn how AI works, which brings me to the sponsor of this video, Brilliant. Brilliant is where you learn by doing. They have thousands of interactive lessons in tons of technical topics. Their hands-on approach helps you understand material from the ground up through lessons packed with problem-solving exercises proven to be 6 times more effective than lectures. It's perfect for building real knowledge in just minutes a day, helping you develop powerful learning habits. If you're interested in learning more about AI, check out their course on how LLMs work and explore the foundations of AI with engaging interactive tools. Visit brilliant.org/purplemind to start your free 30-day trial and get 20% off your annual premium subscription. You can also scan the QR code on screen or click the link in the description. Thanks so much to Brilliant for the sponsorship, and to Marc, who created the project featured in this video and co-created this video with me. On the screen right now is his GitHub page for the code of the Asemic script generator. Marc also has a bunch of other really neat projects, and if you're in the mood for a treat, you should definitely go check out his portfolio linked here. As always, I'd like to extend a huge thanks to you for watching. I hope you enjoyed, and I'll see you next time.